Hey there, welcome back to the second video in the series of making your own DIY self-opening sensor-based trash can robot. In this video, we're going to do the challenge that I gave to you in the first video. And then we're going to learn a few more things about circuits. So just a quick recap. What we did is we have this drawing up here that you see on the whiteboard, and we connected one LED here. And so let's make sure this still works. I have the red is connected to 5V, as we see on my whiteboard drawing, and then the black to GND, which is a common ground, connected to everything else in my diagram there. And I have details on that in my previous video. Okay. All right, so I plugged in and it is on. Okay. So that's good. Now the challenge was to modify the drawing so that it has two LEDs, and then actually build it out. All right, so let's go ahead and modify this. I'm gonna have a second. Might get a little bit messy here, but second LED. I'll label it here. Alright, now the minus side still needs to connect to GND, so I can do something like this, okay? The little dot just means that this GND connects to, or this wire connects to this wire, which is already connected to GND, okay? So that's, it's like an intersection here. We talked about how circuits work like electricity in streets, so this is like an intersection here. And then now the plus needs to connect not to the 5V because that's being used up already on the Uno here, but the 3.3. Okay, so let's go ahead and do that. So you can go here. I guess I could go all the way around like this. Okay, connects like that. All right, not the prettiest diagram here, but correct. Okay, so we'll work on how do we make these drawings a little bit more beautiful later. For now, we just want to make sure that it's correct. All right, so we're good here. Now we just have to build it out. So let's get our second LED. Oh, I have it here. Okay, right here. Let me change my view here. Okay, and there we go. Okay, the second LED. Now the black needs to go to GND, which should be no problem. So let's go ahead and I'm gonna get a brown. I need a socket here, and then make sure that I have a pin on this side that's gonna be able to go into the header here. So I need to go to GND. There's one here. I'm gonna go with this one here. Okay, that's a GND right here. All right, and then now I'm going to use 3.3 now, which is right next to the 3.3 is right next to the 5V. Okay, I don't have another red wire, but what's the closest to red? Maybe orange. Okay, and just so you know, it doesn't. All these wires are the same on the inside. Okay, but the color code just helps us not get confused. All right, so this goes into here, boom, and then now I have two lights. Awesome. So we went ahead and we drew our new circuit diagram using two LEDs, and then we went ahead and built it. Cool. All right, so now that we've done that, let's go deeper into this whole electrical engineering thing, okay? So, all right, so we have these nice LEDs with resistors built in. That's nice. I put them in there in the kit because you can kind of just get things up and running pretty quickly. But we don't always have that. Sometimes you're gonna have your resistor separate from your LED, and then making these connections become a lot more complicated. So that's why you need this thing. I'll show you here. which is also in your Magic Box kit, a breadboard. Okay, so let's talk about this breadboard a little bit. Let me make some room here. Alright, so if you look at the breadboard, you're going to see a bunch of holes, alright? And you see these this red line here. Let me move to this view here. You see a red line here, a red line here, and a blue line here, and a blue line here. Alright, so let's just go ahead and ignore those for now. So this, just like ignore that and ignore that. So just pretend that they don't exist. We'll talk about those a little bit later, okay? So, okay, so those don't exist. Let's look at the inside here. Now on the inside, you're going to see groups of 5 holes. You see that? And if you look at it, each group is on a row, all right? And if you look closely, there's a little printing. It says 1 on mine. It says 1, so this is row 1 right here, okay? And then this is also row 1 right here, okay? A group of 5 holes on row 1. But look, it's separated by this valley right here, okay? So this group of 5, even though it's row 1, it's on this side of the valley, and then this group of 5 is on this side of the valley. That's going to be important. All right? Okay, so let's keep looking at this. So if we look down, how many rows, again, let's just ignore these two parts, right? How many rows going down? Well, if you look at it, it goes 1, and it's printed on there, 1 to 30, okay? So you have 30 rows. Let's go ahead and take some notes here. All right. So here's my breadboard. There's my valley there, right? And then we've got groups of 5 holes. 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm going to draw 2 rows. And then the 30th row. Okay, so 30 rows. All right? And here's the thing that we need to understand here, all right? So these holes here, they're the exact same size as the holes on the Uno here, okay? These headers here. And so you can use the same kind of wire. So let's play with these wires here, right? So I'm just going to take out a white one. So these wires can go into here. And what it allows you to do is, because it's a whole series of all these holes, you're able to connect 2 different things, 2 different wires that have these pins on it, just by sticking them into the same row. See, I'm sticking this into there, okay? And then I'm going to take another one and stick it into here, group of 5. Now check it out. I have the white and the yellow wires. They are on the same row, and so that means they are now connected. All right? If I do this, move the yellow one over, still on the same row as the white, those 2 are now connected. Cool. But what if I do this? Move the yellow over there. White and yellow, they are on the same row. They're on still on row number 1, but they're on opposite sides of the valley, so they're not connected. Okay? Okay, so let's go back to our drawing here. So the way it works is like this, okay? So these groups of 5 holes, there's actually a wire that connects each of the 5 holes. You see that? So there's a wire like that. Okay? So that means if I put something here, okay, if I put something in this hole here, because the wire connects to this hole, if I put something on this hole, they are connected, and also the same as here, here, here. They're all connected because of the wire connecting these holes, okay? And I want you to notice, though, the wire that I'm talking about does not extend to that side, right? Because that side has its own group of 5 holes. All right, and that's all we need to know, okay? So every row of 5 holes that is on either side of the valley, they have a wire that connects them together. All right, and so that's how we're able to make different connections and complex connections using the breadboard. We got to make sure if we want 2 things to be connected, make sure it's on the same row and the same side of the valley, and those things will now then be connected. It might seem a little bit confusing, but as we kind of like try it out, it will become more and more clear. All right, so now that we know that, and I mentioned that there's groups of 5 and there's a wire in there, that means that this is one wire, like this is one wire right here, okay? So based on that, just like a little brain exercise, how many wires are on the breadboard? So one wire is like this one right here. So you can take a second to think about it. So there's going to be 30 rows, right? 30 rows going down. So that means it's going to be 30 times 2 because there's 2 sides of the valley. So we have 60 wires on this breadboard. Okay, so if you take this now, I don't suggest doing this because we don't want to ruin your breadboard here. But if you took this kind of stick foam off in the back, you would actually see the 60 wires here, 30 on this side and 30 on that side. Okay. Now, what's up with these 2 parts that I told you to ignore? So let's take a look at that. So with these 2 sides, this is the way it works, and it's kind of a giveaway. You see the red right here? There's a red line that goes all the way. That just means that all the holes on this column right here next to the red, those are all connected together. And then the same thing though on the blue, all the holes on this column are all connected together. Okay, so there's like a long wire that goes all the way down. Same thing on this side as well. Now why is it plus and minus? Because these are commonly used for the power and the ground of your circuit. Okay, so you remember we talked about common ground. Your circuit's going to need common ground, and so a lot of times G&D or ground is going to be the most popular connection because every single thing you connect needs to have ground. We talked about that in the past video, so that's why there's going to be so many of them. It'll be nice to just access them on here. So I'm going to call this the ground rail, okay, and then this one is the power rail. Now, does the red one here connect to the red one here? It'd be nice if it did, but it does not. Okay, so how many wires then do we have total now? Question, are you understanding what I'm saying here? Okay, so let's go ahead and draw the rest of it here. Okay, it goes dot 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 dot. I'm putting the ground and power rails, so both sides here. Okay, and let's draw in my wires. Is this right? Yeah, red, and then blue. Okay, you probably see it out. How many total wires do we have now that I told you what these red and blue columns are? The answer is what? 64. All right, because you have 60 on the inside and then two on each side for the power and ground rails. And remember, the ground rails from the left and the ground rails to the right, they are not connected. That you can see in my drawing, it's not connected. You can connect them if you want to by putting a wire from on this hole on this side to this side, and connecting those like a bridge. You could do that, but they're not automatically connected. All right, so now that we know that, let's go ahead and do something here. Let's do a challenge. All right, so the first challenge I'm going to give ourselves here is I want to build this same circuit, okay, but now using the breadboard, okay. Now we don't really need the breadboard because I have these nice, it just fits together, but just so we can practice, using the breadboard, let's do that. So let's see. We have our drawing there. The first thing I would do is this, right? Let's connect G and D on the Uno to one of the ground rails over here. So let's do that. Now to do that, I'm gonna have to go look at my kit here, okay? And I need spike to spike, which I have a bunch, okay? Spike to spike, okay? And I have black, so perfect. So let's get a black wire here. And let's go G and D on this side. Okay, and let's connect it to the power rail. Cool, that's nice. So now all of these down here are going to be G and D. That was nice. Okay. And then now we want to connect. Let's use one of the LEDs. Going back to our drawing here. One of the LEDs connects to 3.3, the other ones connect to 5V. Okay? So why don't we do this, okay? I'm just kind of like making this up as we go, so that we can kind of like use this breadboard together. Why don't we do this? Why don't we make one of these power rails, power rails 5V, and one of them 3.3. Okay, so I'm gonna go get a spike to spike. Okay, let's go 5V over here. Let me turn these around so it's the right side up here. 5V here. Okay, and then that is going to go into this power rail. Okay. That works. And then let's get another red wire. All right, let's go orange actually, so that, we separate out 5V and 3.3 with different colors. And let's put this one at 3.3. Okay, and let's put this one onto this side. All right, so now I have a 3.3V power rail, and I also have a 5V power rail. Cool, so then now, let's take one of my LEDs here, and let's put it in the right way. So it's gotta be, going back to my drawing here, right? So the plus goes to the 5V or 3.3, and the minus goes to the G and D. So let's put this one in like this. All right, here's my light here. So the red is on the red power rail, and then the black is on G and D. And so this light should then work, right? And then let's do the same thing with the other light. So the other light, and let me make sure everything's in view here so you can see what's going on with my lights. So I have one light there. Okay. And then my other one, I'm gonna stick it in the same way. The red will go to the power rail. Now this one's connected to the orange one, which is 3.3 for me. Okay? So I got my 2 lights here. Now, will they both turn on? What's the answer? The answer is, let's try it out. Okay? Plugged it in. Only one is on. Okay? And I knew that. Maybe you knew that too. But why? What's going on here? Well, look at this. See my blue ground rail here? There's nothing connected to it. And remember what I said, right? This ground rail is not connected to this ground rail. So that's why this light right here is not working, because there's no common ground to it. So let's go ahead and connect this ground rail to that ground rail. And let's see. I'm going to use blue. Okay. Let's use a blue spike to spike. So here. All right, and then we jump it over to here. And then now they're both working. Okay. Cool. So now we got to practice using the ground rails and experiment with the breadboard. Now, one thing to note here, all right? You do not want to connect the power rails together. Why? Because one of them is 5V and then the other one is 3.3V. So going back to our drawing here, you see one is 5V, one is 3.3V. If you connect 5V to 3.3V, you're going to have 2 power sources connected together, and that's not a good thing, okay? That's like, I guess one way to think about it is you're, let's say you're driving your car on the street, okay? But you're trying to go 2 different speeds at the same time. It's not really possible, right? So what happens, you just overheats and something bad's gonna happen, all right? So we don't want to do that. Do not connect your 2 red power rails together, all right? Okay, so now that we did that exercise, let's see if we can do some more here, okay? And then let's see if we can clean up our drawing too, all right? So I'm gonna keep moving here with our drawing. Okay, I'm gonna turn this off for now. All right, so what I want to do now is clean up our drawings by, let's simplify it by not putting in the picture of the computer and all that stuff, right? Okay, so I'm just going to say uno. Okay, and let's just, for now on, let's just use 5V, okay? 5 volts for everything. All right, and then we're going to have a resistor, and then we're going to have an LED, see, but it doesn't look like a light bulb anymore. This is the symbol for LED, plus on one side, minus on the other side, and that goes into G and D, okay? Now, let's see if we can get these components. So I'm going to take these off, okay? Don't worry, it's just for practice, right? Let's go ahead and take these off. We're going to be doing a lot of breadboarding, so don't freak out that we're taking it apart. Don't worry. All right, we're clean. Let's go ahead and look in our kit here. And we're going to try to find this bag right here, okay? Get situated here so you can see my drawing. By the way, this drawing here that I have here, that I drew on the whiteboard, this is called the schematic, okay? I'll go ahead and write that. So the formal term is schematic, which is what I like to say, it's the blueprint or the plan for your circuit, okay? So kind of like if you're going to create a building, you want to create blueprints before you start building, right? So like when doing like a skyscraper or something, right? You want to create the blueprints before you actually start building the skyscraper. Now, same thing with circuit. So before you build the circuit, you're going to create a schematic. Okay, so you just created a schematic here. Now we're going to get our components or our parts and actually build the street or the circuit. All right, so we need a resistor. Okay. Now the resistors look like this. All right. And there's two different kinds, and you can see that the different color codes on here. All right. One of these is 470 ohm, and one of them is 4,700 ohms. Okay. I'll get to that a little bit later, but different values, different amounts of resistance. Okay. So let's go ahead and grab one of these. Okay. The one that has a red stripe. Okay. Look, the one that has a red stripe. So I'll put these away, and then you could just like pull it out from this paper here. Got one. Okay. Got that. Let's get one LED. Okay, mine's all bagged up. Yours might not be. Okay, LED. Cool. So now we've got these separate components now. Let's see if we can build this up. All right. So first thing, let's do a 5V connection. So let's do the power rail thing. Let's get a red wire, okay? Pin to pin. Connect one side to 5V. Did I get this right? Okay, 5V. And then let's wire up our power rail. Boom. Okay. Got it. And let me turn this around just so everything's right side up. Power rail here. All right, and then let's keep going. I like to build the circuits like this. Okay, we pick a spot. So we're starting at the 5V, right? So you see my yellow highlight. We're starting at the 5V. Let's now add the resistor. Okay, so we're gonna get the one with the red stripe. It says, notice that there are two sides of the resistor, right? Doesn't matter which side. All right, so then we just take one side and connect it to the 5V. Now we know that this power rail goes vertically all the way down, so I'll just put it in any hole going vertically down. So now I have one side of the resistor connected to 5V. That's cool. Now, looking at my highlights, I see the other side of the resistor. Where does it go? It connects to the positive of the LED. Let's look at our light here. The positive is going to be the longer leg. Okay. Remember, we have to do it correctly because LEDs are diodes, and diodes only allow electricity one way. It's a one-way street. So if we do it opposite, it's not going to work. You can't drive the wrong way on a one-way street, right? All right, so we have the positive is the long leg, so that is connected to here, right? Now, how do we connect that? How do you connect these two things? Well, you could tap them like that, but that's not very effective, right? We have a breadboard. You put them into the same row somewhere. So let's use one of these here. So I'm going to take this and just stick it into any row. I'm going to use row number 6 here. Okay, doesn't really matter. Okay, just pick a row. And then I just take the plus and put it in the same row. All right, there we go. And now, you can open that up a little bit. Plus into the same row. All right, we're moving along. All right, the minus I just left open for now. And if we keep going with the minus, is then going to connect to GND. Okay, so I'm just going to put the minus into this row here, okay, which for me is row 9. And then I'm going to connect that row then to GND. So let's make a GND connection. Let's take a black pin to pin. Let's go GND. Okay, and let's connect this to the GND ground rail. Cool. Let's get it in there. Sometimes you gotta wiggle them a little bit. Okay. Looks like I bent that one slightly this way, but we're good. Okay. So I got GND row, and then now I have to connect this row 9 here, because that's where the minus leg of my LED is, into the GND row. So let's do a pin to pin, but I'll do brown. Here we go. Okay. So one side into 9. Okay, other side into the GND ground rail. All right. See if it works. Plugging in. And I have a green light. Nice. All right, let's keep going. Let's add a little bit more to our diagram here, to our schematic, okay? So what if we want 2 LEDs? Well, we could do this. We have a second LED, right? So we're going to draw it in. We're going to need also 5V connection. And we're going to need also a resistor. Remember that resistor helps the LED not explode, right? So we got to make sure we have the resistor. And then we have a common ground. All right. So we're still using the 5V, but now we have 2 LEDs. So let's go ahead and try that. All right. So let's go ahead and get another resistor. Let's use the same color, the one with the red stripe on it. Let me zoom in here. Okay, one with the red stripe. Let's pull that out. Okay, so now we need, let's go ahead and I'll use a different color this time. So I'm going to go ahead and leave this in here. I'm going to use a green highlight this time. Alright, let's first connect the resistor, right? So my second resistor needs to connect to 5V. So where's 5V? Well, 5V is on this power rail, right? So I'm just going to go all the way down here. Boom. Okay, and then the other side of the resistor needs to connect to the plus of the second LED. If you look at the drawing there. So let's get another LED. Okay. Let's open it up. And similar as the other one, right? Okay. We're going to go into a row. Something like that. And then the plus which is the long leg, needs to go into the same row so that it connects to the resistor. And the minus is automatically, for me, just going into the row beneath there. Make sure you can see this. Okay? And then now I just make one more connection, which is my common ground connection, my minus to the GND. And I know that my blue power rail, or sorry, not my blue power, my blue GND rail is my common ground. So I'm going to use, I need a spike. Do I have another brown? I guess I have a black here. Black is good for GND. Another black spike to spike. And let's make this connection to the minus leg of the light to GND. And I got two lights. All right, so I'm gonna disconnect this for now. And I want to give you just a note here. You see, when I was doing it, I had this plugged in the whole time. I'm super careful. I've done this a million times, and so I left it plugged in so you can kind of see it turn on right away. But the safer thing, maybe what I should be doing is to disconnect it first, then make your connections, and then plug it in. Okay. The risk is that if you take, let's say you're messing with the LED and trying to put it, and you accidentally touch a metal part that, accidentally, that could cause an issue in your circuit and cause some damage. Now, I'm very careful. That probably won't happen. So then that's why, I wanted to show it to you with it plugged in. But now that I'm talking about it, go ahead, when you're changing your circuit, go ahead and unplug it first, make your connections, and then plug it back in. Okay? All right. So now we have two lights. Let's see how many LEDs we have in this kit here. I think there's a third one. So here's what you're going to do. All right. Your challenge is go ahead and modify your schematic so that you have 3 LEDs. Okay. And then go ahead and build it. So you're going to have 3 LEDs. And then you're going to build it. All right. And then go ahead and do it for 4 LEDs and then for 5 LEDs. So how is that going to work? Well, you have 3 of the, these are called discrete LED components with the resistors, all right? But you also have these 2, all right? Now these 2 have built-in resistors, so you don't need extra resistors for these 2. So give that a shot, all right? So the first one is create a 3 LED schematic, build it. That's going to be very similar to what we have already. And then go ahead and do a 4 LED schematic, build it, and a 5 LED schematic. With 4 and 5, you're going to need these 2 LEDs. So by the end of it, you're going to have 5 LEDs all on at the same time. And your breadboard might look a little bit crazy, but that's good because we're experimenting with the breadboard. All right. Now the last thing that I want to mention, I gave you a little, sneak peek already, but let's go back to my whiteboard here. Okay, remember I said the resistors, right? So the resistors, you got one with the red stripe, okay? And then you have one without the red stripe, all right? So one of these resistors is 470 ohm. One of the resistors is 4,700 ohm. Okay. Now, the ohm is just the unit for the resistor. Okay, so 4,700 is the bigger resistor. 470 is the smaller resistor. Okay, so given that, and then given the LEDs, and then given the circuits and things, and the ability to experiment, I want you to think about and experiment you're gonna have to think and experiment. Which one of these is 470 ohm, and which one is 4,700? Okay. Now, how are you gonna do that? The hint is that when you hook up the resistors, the light will be dimmer or brighter, right? And that should tell you something. And we experimented with the dimming and the I guess dimming and then the increasing in light using different voltages, right? In the first video. In the first video, we said we connected it to 5 volts and we saw it was brighter. We connected to 3.3 volts and saw it was dimmer. Now, what happens when we change the resistance? It's going to get dimmer or brighter depending on the resistance. So I just want you to kind of think about that a little bit. I'll show you the answer in the next video. But give that a shot. So those are your challenges. Create those circuits up to the five LED circuits, and then also figure out which resistor is which. All right, that's all for now. If you have any questions, always feel free to reach out. Hope you're enjoying this playing with circuits so far. The next video, we're going to start playing with buttons so that our LEDs and stuff are going to be able to react with the world with the easiest sensor, simplest sensor, the button. All right, so we'll do that on the next video. Thanks, and I will see you next time.